In this video, we're going to be talking about how to work backwards with the volume of a cone. So if you're given the volume, you might be asked to find the area of the base B. Or if you are given the volume, you might be asked to find the height of the cone H. So in this video, we'll talk about how to do those through some examples. In this first example, we're going to learn how to calculate the area of the base. So this problem states the volume of a cone, V, is 718 cubic units. The height, H, is 14 units. Calculate the area of the base, B. Round your answer to the nearest hundredth. So just like when we were working backwards from cylinders, we're going to start off with the formula for the volume of a cone. So a cone is V equals base times height, all divided by 3. Next, I'm going to start substituting in the information that I know. So it first tells me that the volume, V, is 718 cubic units. So I'm going to substitute that 718 in for V. I don't know the area of the base, so I'm going to leave that as B, but I do know that the height is 14. So I'm going to make that substitution as well. And then that divided by 3 is always there. Notice for this problem, I left it as capital B instead of putting in like the pi r squared in its place. And the reason I did that is because that's what I'm looking for. I'm looking for the overall area of the base, not the radius, which we'll see later. So for now, I'm going to leave it as capital B. So now that I only have one variable in all of this, I'm able to solve by working backwards. So the very first thing I have to get rid of is the divided by 3. So to do that, I'm just going to multiply each side by 3. That would cancel, leaving me with B times 14. And over on the other side, I'm going to actually be doing 718 times 3. So for that, I get 2,154. So in my very last step to get the area of the base, I'm just going to divide both sides by 14. Ooh, it's not a nice answer, but the problem says round to the nearest hundredth. So my final answer from 2,154 divided by 14 gets me 153.86 if I round. And since it's area of the base, my units would be square. So in that example, we were finding the overall area of the base, B. In this next example, we're going to be looking at how to find the height. So here the problem says if the volume of a cone, V, is 4,710 cubic units, the radius of the circular base is 15 units. I know that that's R. And then it says calculate the height. Use 3.14 for pi. So I'm going to start off the same way I did last time by just writing the formula for myself. Now, if you notice, it doesn't talk about overall the area, it talks about the radius. So I'm going to want to kind of break that down further into my pi r squared times h all over 3, just since I'm using the radius this time. Just like the last problem, once I get to this step, I'm now going to plug in what I know. So in for V, I'm going to put 4,710. Actually, in for pi, I'm going to put 3.14. In for the radius, I'm going to put 15. And I don't know my height, and that divided by 3 is always there. Okay, so now I get to start working backwards. What I would do first is multiply by 3 to go ahead and get that out of the way. So I'm going to take that 4,710 and multiply it by 3. It gets me a fairly large number of 14,130. Now, once I get to this step, I have a couple of options. Sometimes people like to take this in parts. So you can divide both sides by 3.14 and then divide both sides by 15 squared. You could also go ahead and multiply all of that together to then divide it only once. I'm going to show you just in pieces, but again, it's up to you how you want to do that. So I'm first going to divide by 3.14. That leaves me with 4,500. And then on the right-hand side of the equation, I have 15 squared times h. If you prefer, you can go ahead and figure out what 15 squared is. That's fine. For me, I'm going to leave it, and I'm just going to divide both sides by that 15 squared. So once I do that, that gets me my final answer because h would be by itself. So 4,500 divided by 15 squared gets me 20 as my height. Okay. In this last example, we'll be working to find the radius. So the problem says the volume of a cone, V, is 84.78 cubic units. The height, h, is 9 units. Calculate the radius of the base. Use 3.14 for pi. So again, I'm going to start off by writing my formula. And again, it's talking about the radius of the base. So I'm going to keep going on this formula, and instead of capital B, I'm going to write pi r squared times h. Once I have that, I'm going to plug in the information that I know. So for V, I'm going to put this 84.78. For pi, I'm going to use 3.14. I don't know my radius, so I'm going to keep that there for now. And then it says the height is 9. And all of that is over 3. So we need to start eventually working our way to get r by itself. Just like the past two problems, the first thing I'm going to do is multiply both sides by 3 to get that to go away. So 84.78 times 3 gets me 254.34. I still have my pi. I'm eventually looking for r squared, and I have 9. So next I need to start getting rid of the numbers that are with r squared. So I'm going to first divide by 3.14. That gets me 81, and that's equal to r squared times 9. So I'm getting closer. Next I'm going to divide both sides by 9, and 81 divided by 9 just gets me 9. So it almost looks like I'm done. Right now I have 9 equals r squared, but I'm not quite there because r is still squared, and I need to undo that square. So the inverse of squaring is square rooting. So that would give me my final answer of 3 units would be my radius. So in summary, for working backwards at the volume of a cone, you're first going to start with your formula. If it's talking about the overall area of the base, you can use just capital B. If, however, it's ever talking about the radius, you're going to want to break that down further and use pi r squared instead of capital B. From there, you're going to plug in what you know. Since we're working backwards, you're going to be given the volume and then decide what else you're given. In the end, you should only have one variable left, so you're going to use inverses to keep working backwards and solve. Good luck!